Perfect. Perfect. Thank you very much, Kevin. So, as some of you might know, my name is Mathias. I usually go by IIS. Reset me. Yesterday, Kevin sent out a call on the Swiss Usergroup Twitter to ask if anyone has had any demos they would like to present last minute. I've been working on a series of blog posts on sort of fundamentals in PowerShell and in authoring PowerShell. And one of sort of the first examples in that series, I thought, you know what, we could probably turn this into like a nice 20-minute demo. So that's what we're going to do today. I'm going to show a few slides, and then I'm simply going to walk you through the sort of the evolution of a script or the evolution of an advanced function. So we're going to try and do that. As Kevin mentioned, this is going to be in English. Mein Deutsch is schrecklich, as you might agree from that. So we're going to do this in English instead. So this short demo is called Parameterize, Please, Tips and Tricks for Authoring a Nicer PowerShell User Experience. So what does that mean? Well, many people, when they start out writing PowerShell and sort of start expanding the applicability surface of the scripting language, usually what we see is there's a bit of a learning curve, right? But the barrier to entry is pretty low. So it's very simple. You just sort of like open Notepad, right? You write a script, a couple of statements that does some stuff. Maybe you schedule it as a task, and all of a sudden, boom, you've automated part of your workload, right? So the barrier to entry in sort of starting to automate your workloads using PowerShell is extremely low. You just sit down, write a couple of scripts in a text editor, and you're good to go, right? After a while, what you find is that maybe you're repeating yourself in scripts, maybe you're copy-pasting the same lines of code over and over again with sort of minimal changes. And so you start looking into the documentation, you find out that PowerShell, at least since version 2, has this pretty fully fledged scripting language, right? And one of the things you can do is you can define functions. And so functions are a little bit like the contents of a script, right, or a script block. You just give it a name, and then you can sort of reuse or reevaluate the same code over and over again. The nice thing about functions is that they take parameters, right? So we can pass some input to a function, and that means that, again, if we end up in this situation where we sort of copy-paste the same code over again, but it's the same values that we sort of, the same variable values that we end up changing every time, we can sort of now parameterize those, and now we don't need to copy-paste our code anymore. After a while, you might find that you need something a little more advanced, or you want to provide support for pipelining, right? This is sort of a very common pattern in PowerShell. You have a commandlet or an expression that produces or outputs some data, and then you sort of stream it along the pipeline to the next function that then sort of works on it iteratively, and so on and so on. And so in order to support that, you might run into that you either need to write a commandlet in C#, or you can write something called an advanced function or a scripting function. And so we're sort of going to look at an example of what this journey might look like from a script to a function to something that looks like a commandlet, and why that might be nice. First of all, why should I parameterize, right? Why is this important? Well, if I can leave you with one thing, right? If the next 20 minutes of demoing sucks and you think I'm bad, then at least take this with you. In PowerShell, parameter sets is the user interface. So if this doesn't make any sense, if a parameter set, what is that? Don't worry, we'll cover it now, but I really want to sort of impress this on you. The parameter sets of a function or a commandlet in PowerShell is the user interface. If you see yourself sort of as the developer of a piece of software when you write a piece of PowerShell, right, which is what you are, then there's a user of this. The user might be yourself, but the user experience, right, and the way that your user interacts with and invokes the code that you're writing, be it a script, be it a commandlet, be it a function, is the parameters that we're exposing to the users, right? How do we expect the user to sort of interact with it and change its behavior? So again, sort of, I can leave you with anything, parameter set in PowerShell. And this is why it's important to sort of think about how you parameterize things. So for this demo today, I've I've sort of come up with an artificial function, but it's actually not that far from something I had to write very early on in my career. And that sort of started out as a simple script with some hard-coded values. It was one of the first examples where I sort of started delving into how could this be a nice reusable function. So this is from memory. This is not code I use in production, but the patterns will sort of be the same. The script or the command that we're looking at today is going to be called update XML file. As you can imagine, it's going to take a path to an XML file and it's going to update some attributes either inside the file or on the file itself. As you might imagine as well, since it's an XML file, it takes a file path, does something. But if we're working with file paths, wouldn't it be nice if they also supported things like wildpath and pipeline?
Just quickly, jemand ist nicht gemutet, bei dem gesprochen wird. Kann ich fragen, dass diese Person sich noch kurz mutet? Vielen Dank. Okay, you can continue, thanks.
All right. So, with that in mind, and hoping that everyone muted themselves correctly, here I have sort of version 1, sort of the ground zero of the script or the function that we're going to use with today. So I call this update XML file v1. Simple script. We have some hard-coded values, right? We have a hard-coded path to a file, in this case an XML file. We use getItem to resolve and obtain some sort of handle to this file on disk. Maybe we want to open the file, do something with it, change the contents. It's not really material what we're doing to it, but the important part here to notice is that the input we're taking from the user is some sort of file path, and we need to locate and act on the corresponding file on disk. And so in this case, we're sort of just passing this file path off to getItem, and now we sort of have an object we can work with. So in this case, where I wanted to add the archive attribute if the archive attribute doesn't already exist in the file, I can sort of do it against this object that sort of infers from this hard-coded path. Okay, if you're new to PowerShell, or if earlier in your career you did sort of these kinds of common Windows server management or infrastructure workload automation, you might have seen something like this before. You might have written something like this before. I certainly have, right? So, okay, this is all fine, but then next day the application owner or your boss comes down and says like, oh, the script you wrote works fine. We're running the once every hour. It solves all of our problems, but we need to apply to a couple more files. So, okay, what do? Well, as I said, you might just sort of copy-paste all of this, and now you have it repeated twice, right? So now we have a hard-coded value for the first file path, and then down here we have another file path. I think this should be 2, right? And now we have a set of duplicated variables. We're doing the exact same thing over and over again. The only thing that changes is the value that we hard code and provide for this file path or whatever's going on there. Okay. So, okay, fair enough. We're still less than 30 lines. It's probably fine. So you update this, you save it. It's all good. A month later, your boss comes back and says, "Oh, one of your coworkers is complaining that the script is now unmaintainable." So you have a look at it, and it turns out that someone had the great idea of adding another 5 files to this mess, right? So at least someone sort of like moved all these hard-coded variables up here to the top, so at least we can add another one. But now we need to keep track of, okay, we've reached file 7. If I want to add a new one, then I need to do something like file 8, and I'm copy-pasting so like repeating myself again. So this is not good, right? Again, we're up to almost 100 lines of code for something that we're sort of just repeating ourselves. And again, this is sort of unmaintainable, right? You need to do way too much to either remove or add a new file to this workflow. And so this is where you might go in and say, maybe if we're repeating ourselves, let's use a function instead. So, okay, what might a function look like? The simplest function definitions you can come up with in PowerShell actually look a bit simple like this, right? You sort of just use the function keyword, then you give it a function name, and then you provide a script, right? This is the simplest function definition statement we can come up with. Function definition statements also support a list of parameters that we can then pass corresponding arguments to. And so this is what I've done down here. The variable part of our code, in this case the file path, I've sort of smacked in between two parentheses here after the function name. And what this is going to do is I have a default value here. So if I run update XML file, this hard-coded value is going to take the place of file path inside the script. But down here, I now also have the option to sort of pass something custom to this name parameter file path. And so now I can run it once, target the first file, I can run it again, and then target a second file. And notice that all of sort of the meat of the code, obtaining the file handle, editing my XML, updating the attributes, so on, none of this is repeated anymore. Okay, so this is pretty nice, right? We've already cut our code down to less than 20 lines again, and we can now sort of add multiple paths to this if we want to, right? Like we can just keep adding just single line statements, this file path, XML file, right? And so, okay, maintaining the script is already way better, right? We just add a single line. Okay. So, next up, someone comes in and says, right, okay, but I read somewhere that, in PowerShell, this flexible language, right, you should be able to sort of like just pass these values around with the pipeline, right? And also, what is to stop someone from passing an argument that's not a file path up here? And so, okay, let's have a look at what the next evolution looks like. This is sort of where we get into what we call advanced functions or script commandlets. That is, instead of having our parameters in a set of parentheses outside the function name here, all of a sudden we had this inline param block. And so, to be honest with you, what happens when PowerShell sees this annotation with the parameters right after the function name? It says, I'm going to interpret it as this. So PowerShell sees this when you actually do this. The reason this syntax exists is to help people who came from other scripting languages or programming languages like JavaScript or C# to sort of easier adapt to some of the syntactical differences between these languages and PowerShell. But really what PowerShell is doing in the background is this. Okay. So in this example, kind of stepping up our game here, we now have an explicit parameter block, and we specify explicitly that we're interested in a string, right? The path to the file is a string. So, okay, no material changes to our code yet. What would it look like invoking this? Well, instead of adding separate invocations of update XML file like we did in the previous script, now we can sort of organize all of our input here, right? Here we have an array of just the two file paths that I want to act on. And then we could do something like type it to for each object, or use it in a for loop, or use it in a for each loop, and then call update XML file path, and then a reference to each of the variables in that array. Now maintaining the script becomes super easy because it's literally just adding a single file path to the array of input values that we have. So, boom, I did my update, I can go to lunch now, right? Super easy to maintain. But then maybe one of your colleagues goes to, let's say, a PowerShell conference, and he sees all of these smart people writing code that can do all sorts of weird stuff, like, for example, take the strings and just set them directly to update a file without all of this for each object nonsense and multiple invocations in between. So how does that work, and why is this not currently working? Okay, so the next iteration or evolution of our advanced function here is to add something called a parameter attribute declaration, or parameter attribute. So the idea is that before the name of the parameter here, we have this set of blocks. It sort of looks like a type name, right? And then we put the name of the attribute that we want, in this case the parameter attribute. And then in a set of parentheses here, we can specify a set of options. So these are behavior modifiers, ways of modifying the behavior of the following parameter. So what we're saying here is that the parameter file path should now accept value from the pipeline. Okay, so if I define this, let's have a look at what this actually does. I'm afraid that this is not going to trigger because all the files and directory and everything are actually archived. I'm just going to remove this, but basically it's the same. We obtain a reference to the file, and then we call a write host down here so we can just see what we can do. I'm going to take this, jump over into Windows Powershell, Powershell 4 as well. Not familiar so much. I'm just going to copy the file here. I'm going to define my function here, update XML file, and so if I run it like before, update XML file path, XML, it works as expected, right? Okay, it fetches file at XML, updates the attributes. Okay, so far so good. But what we really wanted to support was pipeline input, so let's test that. The string here, we pipe it to update XML file. Sure, this works as well. But here comes the kicker. This is not going to work as long as I pipe more than one path to it. And so anyone who has tried to add pipeline support for multiple inputs to a function might already have caught what's going on here. But if I try this, I have to update XML file. It seems to only work on the last file that I input to it, right? Our paths variable up here has two values, file.xml and file2xml, but I'm only getting one of them when the function executes, right? It's only operating on one of them. So what's going on here? So what's going on here is that by default, a function will execute something called an end block. And so what's an end block? In order to understand that, we need to look at sort of the true nature of what a partial commented is. If you log into the documentation for advanced functions in PowerShell, you might have seen that you can do something like function, yes, function, parameter block, that it supports these three keywords called begin, process, and end. And so what's actually going to happen when you use a command lib in a pipeline is that as soon as the pipeline starts executing, as soon as the first expression in the pipeline is executed, this begin method is going to be called once with non-pipeline bound input. So that means that the begin block is going to be called once at the very start of the entire pipeline on every single command that you have in there. So if we do something like, I have my get stuff command up here, maybe I do some where objects, there's some filtering going on here, and maybe I do some stuff here. As soon as this statement starts executing, the corresponding begin block, if any exists, will be executed for both get stuff, where object, and see object. The next thing that happens is that for each piece of input that each command lib receives from the upstream command lib, in this case the upstream to where object would be get stuff, every time a single piece of input that is pipeline bound is accepted, the process block executes exactly once. And so that means that if I pipe 10 objects to a command lib that takes pipeline input, the process block is going to be executed 10 times. Finally, there's this end block down here, which is, as the name might imply, executed only once at the end of the pipeline execution. Now, you might have noticed in the previous example down here, I'm not using these begin, process, end keywords. And so what PowerShell does is that if you don't explicitly declare any of these three blocks, it's going to assume that the body of your function, all the code that's in this case in here, is going to be treated as a single end block. And so that means that by the time that the actual code that I have left down here is going to be executed is at the very end of whatever input has been piped down to me. And this is by only the very last value that we tried to use the pipeline to find the file path actually exists. So we've sort of skipped over all the first values, and now we're only operating the last one. So how do you fix this? Well, simple. You just let's go here. You simply declare the process block up here, and so now all of this code that we have in here is going to execute not once at the end of the invocation, but once for every single piece of pipeline input. Now, I've made a few more subtle some changes here. One that is worth noting here is that I changed the type of the file path parameter from a string to an array of strings. And so this is sort of important if I still want to be able to support the use case where someone does update XML file. Just going to do it over here where it's a little more visible. I still want to be able to support the use case where someone goes file path 1, path 2, path 3, or otherwise explicitly pass me an array of strings. I still want to be able to support that use case. So for this reason, it's pretty important that we sort of declare this array. Now, in order to get around the fact that the file path is now an array, this type is going to persist inside the process block, even though we might only have a single piece of input item. We might only have a single string to work on. So we need to treat this as an array. And so in this case, I've simply wrapped it in a for each loop in the process block. This is super common and super easy to happen if you want to support both pipeline bound and non-pipeline bound input values in each step. So in this case, it would be the value of this value item here. So now, not that much more code, right? I just declared the process block, and then I wrapped everything in a for each loop. And now, with this, once again, I'm just going to comment this out so it doesn't get any this. Paste this. I'm going to go back to my previous example where, again, I have two paths in here. And now, all of a sudden, because of the for each loop and the fact that we've changed the type of our input parameter, we can now work on both inputs or multiple like that, however many file paths in here that I want to. At the same time, as I said before, we're now also supporting passing either a single value here or passing an entire array, and we still get the exact same behavior. We iterate the entire thing. All right, so our use case down here with piping to update XML files no longer broken. This is awesome, right? So far, okay, good job, right? Like if I saw someone starting out with PowerShell coming up with anything like this, I'd be impressed, right? This is pretty cool. So okay, next thing that happens, someone else comes back from another PowerShell conference and says, "Oh, I saw something super cool. A lot of these commandlets, you can sort of just discover the files already. Maybe you have a statement like some for XML. Maybe you type this to where object or do some other filtering on it. Let's say we're only interested in XML files over a certain size. Then we can now start doing our filtering before we invoke our function, and then take these file info objects and pipe them to update XML file. This would work with any of the provider commandlets, so and a bunch of Microsoft supplied modules. So why wouldn't this work with our own? The problem with this is that if I start running this, I'm not going to do it right now, but we're going to get either a big fat error or we're going to get some very weird behavior depending on the current file path that we're on. And so how can we support both taking paths, which are just strings, but at the same time also accept input that happens to be these file info objects that get child item would return when you query the file system provider. And so this might be easier than you think. In fact, I've only made one change in this version of the script. Go to the top here. The only change I've made is I've added this alias for for a property name called PSPath. And this is going to work. This is going to work just fine. In fact, I'll prove it here again. And then, again, as I said before, I'm going to obtain these file info references. Right? And then I'm going to put them to our new updated raw file. And if for some reason it doesn't work, oh yeah, right. Always great at the demo failure when I just guarantee that it absolutely works.
Maybe it's because it. Ah, no. Yeah. Sorry.
Well, I stuck something here. Well, maybe we'll clear it up in the next one. Okay, so I'm sure we'll get some clarity in the next demo. Okay, so you might ask, why did I ask this PS path thing? Okay, first of all, PS path is something that gets added to every single item that gets returned by the provider commandlet. So what's a PS path? A PS path is a specially constructed PowerShell internal path that is used to distinguish between providers, right? So we have these PS providers, right? Registry, alias, environment, file system, functions, variable certificate, WSMan. If you've worked with the ships module and open source module, you can even sort of add your own providers or your own provider wrappers. So that means that PowerShell needs some way of distinguishing between something that's a relative file path and something that's a relative path to an item in one of these providers without it necessarily being a file path. And the way it does this is by attaching an artificial property or a hidden property called PSPath. And this is pretty easy to sort of show. Get back in this folder here. I'm going to type this to get member. I'm going to use the force switch. And down here, you can see that there's a bunch of node properties added by the Mathias system to this file or this directory. So one of them is right here, it's the PS path. Okay, so I've discovered that this PS path property exists. But why am I adding it to my function definition? Well, to show you how just that, right? So here again, we can see we have a fully qualified provider name here, then the provider drive, and then finally the relative path to the object that we're working on here. So how did I find out that PS path was something that I wanted to alias? So I'm going to show that real quick. The behavior that I'm after, I'm just going to make this a little bit smaller. The behavior that I'm after is exactly the same as with the provider methods, right? Get item, get child item, so on and so on. So, okay, let's see what they actually do. If you've ever wondered, I wonder why PowerShell is acting a certain way or why it's finding parameters in a certain way, I will strongly encourage you to look into this command that ships with PowerShell called trace command. Trace command is going to instrument PowerShell to output a bunch of super verbose tracing output from a set of tracers that are implemented in the providers themselves. So anything sort of intrinsic to PowerShell's engine behavior itself, or anything that happens at the provider level, we can actually get some really verbose output by simply wrapping an expression in trace command. So what we're going to do here is we're going to do trace command expression file get item, and then I sort of want to see if we can figure out how get item translates this file item into a path that it can target and then reapply it. So for this, we're interested in something called the binding tracer. We're simply going to ask for anything from any provider with bind in the name. Finally, I want to output this to PS host. Normally, you would output all of this to file. So I'm going to hit enter here. You can see we get a bunch of debug output here, and it's probably not super readable with this super massive font size. So I'd recommend going home and sort of trying this experiment. at home in your own shell. But what we can see here is that at some point, it actually binds the input value that seems to correspond to this PS path, this PS path value to the literal path parameter of getItem. And so you might be wondering, how does that even come about, right? Like literal path is not the same name as PS path. How are these two bound together? Well, if we dig a little deeper and have a look at the command info for getItem, just going to save this here, and we then have a look at its parameters. Let's have a look at this literal path parameter. Sure enough, down here, there is a parameter alias on the getItem, and for that matter also getChildItem and a number of the other provided commandlets for literal path that aliases this to PS path. The reason none of this works is that I've only specified value for pipeline. That is, I'm going to take the entire object value and bind that as my pipeline input. In order to support this scenario, we're going to have to add support for something called value from pipeline by property name. As soon as we turn this on, the Powershell parameter binder is going to see that update.xml file supports something alias to a property name PS path. And since all the file info objects have a PS path parameter, it can now safely bind that to our to the input value of the parameter that we have in update.xml file. So this should fix the issue that we saw before. Well, once again, here, update. For same problem as before. Oops, we got this statement here. And sure enough, now it correctly binds the file path to my file path parameter, which is then further resolved down the chain. Finally, all right, so now all of these nice use cases, we can both type file info objects, we can type strings, and we can accept arrays of strings or arrays of file info objects. The only thing that we might run into at this point is how do we support wildcard input and how do we support literal input, such as when using the literal path parameter with getChildItem or getItem? Well, we sort of just emulate the parameter definitions of the provider commandlets, but in this case we specify that our parameters belong to two separate parameter sets. So that means that path, which would accept wildcards, becomes mutually exclusive with literal path, because literal path is only accepted by this other parameter set down here. Finally, we add a commandlet binding to our function. If we had not done any of these parameter declarations, adding a commandlet binding to the parameter block would also change the behavior of our function slightly, in that we now get access to something called common parameters. That means that we can do stuff like the file verbose, and it's sort of going to propagate down the call chain, debug, so on, As soon as you start declaring either an explicit commandlet binding or an explicit parameter attribute on parameter in your param block, all of this behavior comes for free, because we've now sort of switched from a simple function to, again, a scripting commandlet or an advanced function. So this is sort of the demarcation, right? All of a sudden we get all of these nice behaviors with all the common parameters, and we don't need to do stuff like doing our own debug switch or anything like that. Please don't ever do that. So now we have these two parameter sets. So by default, if I go down and do something like update XML file, and then pass here. Oh yeah, finally, one more thing. Instead of having to check, so the first time I had to implement this pattern, right, wildcard path versus literal path, I started doing something like this, and begin block, and then if path has a count of more than 0, is literal, I'm going to set something here, and then, so I started doing a bunch of validation for whether I was using one or the other. Now, all of this is completely unnecessary. First of all, in order to check whether we're on the literal path or path parameter input when we're using pipelines, we can check the PS commandlet automatic variable for the parameter set name. In this case, if I use this invocation down here where I'm piping and hoping to bind PS path to literal path, this would come back with the value by literal path. Whereas if I do update XML, I'll some value here, this value here would come back as default. So first of all, if you explicitly need to check which parameter set has been chosen, don't start inspecting the parameters themselves. Just look at the PS commandlet automatic variable. This becomes available as soon as you've sort of upgraded your function to an advanced function, either with a param block or a commandlet binding or both. So PS commandlet parameter set name if you want to evaluate what parameters that has been chosen by the user. The second thing is, I would do stuff like if the parameter set name equals path, then I'm going to do one thing down here. Maybe I'll do, resolve path. I'm going to path. I'm going to type that get item maybe, and then down here I would have a second branch for the other case where I would do like, okay, it's the literal path. I do get item the literal path. Then I found out about PS bound parameters. PS bound parameters is another one of these asymmetrical variables that only show up in certain contexts. PS bound parameters is a dictionary that contains all the parameters to which any user value and user arguments have been bound. And so what I can do when, regardless of whether I'm using the literal path or the path parameter, I ultimately want to just pass it off to get item, right? I'm sort of trying to replicate the user interface of get item so that I can pass some acceptable input off to get item, right? So if I just want to pass it off directly, and maybe I also want to sort of explicitly propagate all of these types like verbose, error, and whatever else could have been in there, instead of having a big switch that checks for whether any of this was found, just take the dictionary, the PS bound dictionary, and then we split it. And so in this case, again, I'm just going to use get item as is, splatting all of my parameters as the user originally input them to me without touching them at all. And then the result of that, whatever file info object is being returned by get item, I'm then going to operate on that instead. So this again, let's go out and sure enough, with a single file I can still pass to it. And indeed, if we look at sort of trace command, same trig as before, so at some point up here, you're going to find that indeed it did the exact same thing. It resolved the fact that literal path has an alias that matches one of the input parameters, and we bound it that way. So with this very simple parameter declaration and a single commandlet binding, I've now sort of replicated the exact same user interface because, again, the parameter set that you expose to the user is absolutely the user interface to your code, to your functions, or to your commandlet, right? I've now replicated part of the UI that makes getItem really nice to work with in my custom function that then sort of wraps that call to getItem and does something. So now whoever picks up my update XML reusable function here and needs to either use it in a different context, or they need to maintain the script that updates all of these files or has all of these file names. In any case, regardless of sort of their level of experience, they can now use this any way they see fit, right? They can pipe files to it, they can pipe paths to it, they can pipe relative paths to it. Again, getItem is going to take care of it for us, and they can explicitly pass input or an array of inputs to it should they feel like it. And so I no longer need to worry about sort of my users holding my function wrong. I've sort of made it sort of nice and a little bit foolproof in this way. That was sort of all I had for today. I hope I didn't run too much over time.
Cool. Thank you very much, Matthias.